Hey everyone, I'm Samson Koshy, and I'm from MinIO. So today we're going to talk a little bit, chat a little bit about migration, what that means. Migration is a very subtle topic in the sense like everybody's world of what migration is completely different, and every company is completely different. So we'll go ahead and have a little bit chat about what that is looking like, and we'll be curious to know like how many of you are planning to do a migration and or have done a migration before. That's another question I wanted to ask. So one thing that I wanted to quickly cover on migration is really it involves a lot of planning. The easy part is actually to transform the data from one source to the other. That's the easy part. I mean, there's some technicalities associated with it, but if you want to convert A to a small letter case A, for example, that can be done. Or if you want to convert data from a particular format, maybe CSV or JSON or maybe even Parquet or protobufs or any other type of data formats that you have into, let's say, Iceberg, that is possible to be done too. So that is not the hard part. The hard part is actually for your business in terms of like what you're delivering. How can you ensure that it's up 24/7 or there's no impact to the company per se while this migration is happening? And some of the properties associated with that are things like costs. It could be that you're on an old hardware, or you have a point where you're not reaching enough throughput to scale, and you need to actually have a bigger network, a bigger set of drives, a faster set of drives, and maybe even for how it's going to be accessed. So if it's Iceberg, it can be accessed as SQL, so your analyst and your data scientist can use it straight away. They don't have to write elaborate transformations or code in order to get it in the way they want. So that actually saves a lot of time and effort down the road. So those are the important aspects of it. So yeah, so important thing is to kind of do the planning on it in terms of what that is. Some of the things that I want to cover in terms of that is always think about like how you're going to execute it. So have a playbook in terms of this is how we want to actually run by it. So like set up some guardrails, set up the strategy in terms of what that means. Um, some of those things are associated with costs, as well as you care about performance. You also want to care about governance, like who can see what type of data, how it is processed, and how it's actually transformed. Like if you look at the medallion architecture from raw data to silver data into gold data, right? So those are the important aspects. What I'm going to do is, as I'm going through, I'm actually going to give a brief introduction on how to think about migration. And then we're going to step into, actually, I'm going to do a demo and just show you how you move data from, I took the example of JSON to Iceberg. And then once it's an Iceberg, I can show you a notebook that you can query Iceberg data right away and see what that looks like. And then we can step into defining a little bit more about how do we go about planning on the migration. So important part, like I said, is when you step into migrating your systems, one thing that you want to keep in mind, like I mentioned, is to figure out what that playbook looks like. So there might be several steps where you understand what your inputs, where it's coming from, and how you're going to transform it and what those outputs are going to be, right? So let's look at one example over here. In this example, as I go down, you can see that when we get the data, well, the first thing you want to figure out is build the data contract and figure out what that is supposed to look like, what the schema is supposed to be, how that schema is going to be defined, what's your current schema, and what your future schema is going to look like. And it should be the same, but the formats are going to change. So, and then when it goes into that level of detail, you get to a point where you have to figure out how are you going to actually go through the playbook. So sometimes there are some reports and some data sets that need to be live and up and running at the same time. So you may think about, okay, I'm getting the source of data that I want to process, that's writing it into CSV and JSON, for example. But you can dual write that and pull the same source of data and produce Iceberg data sets while that's happening. And then there'll be a point where, let's say you have 7 years worth of history or 5 years worth of history. You could actually go and do batch processing for all the data that was in the past and convert that over, while the new edge data like that's happening on a daily basis is dual writing to both Iceberg and to your old format. Then you have reports on top of that that would query that, and you would compare side by side and to make sure those numbers match. And that's when you know that this particular type of pipeline that was writing to JSON or CSV is showing the same results while when the same set of data for that is writing into Iceberg. And then you know that, okay, at this point I can shut down this pipeline and then focus on the next one. And that's how you go about it. And some of these pipelines are actually interconnected with each other, like they're dependent on each other. And so as far as that's concerned, you have to really figure out and be, I would say, really careful in terms of how that's done. So let's go through a process of running this code. Any questions so far? Just feel free to chat and we'll respond to that. Yeah, so the question was, what is the recommended REST catalog for Iceberg on-premise? So Nessie has been is pretty good. It really depends on what you want to get out of it. So for instance, I've seen like in the industry, Nessie has been used a lot, and there is it's been more battle tested. So I would pick that, but you also want to make sure, like, what do you think about maintenance for those catalogs? So if it's backed by a Postgres and a database, then you're careful not to lose that information. Then that's great. So those are the things you want to keep in mind. So in AIStor, AIStor tables is a new product, and that's going to come up. And in that, like, everything is a native, including the catalog. I don't think you need to integrate Polaris as well as Nessie. So it depends. Yeah, I don't think you need. If you can write a little bit more in terms of like why you need to integrate, like what you're thinking, I can probably get a better answer on that one. Right. So coming back to this, so let's go and just run a particular. So here I have a so I have a Java pipeline that I'm actually going and generating data. Let me just show you that part. I'm generating data, and it's producing this data and writing it to Kafka. And from Kafka, I'm writing it to MinIO's AIStor. And this is writing it as JSON. Data is not showing here because this MinIO is not up yet. And then from there, I'm going to run this JSON to Iceberg code, and I can walk you through that. And that's actually going and talking to Nessie, creating the namespace and the table. In this case, Nessie raw events, and it's writing it to Nessie at this point. And then I'll go through the I'll go through a notebook associated with that, and so we can see how that looks, and then we'll come back to the migration aspect of it. So let me just run this piece of code. So this is compiling all my producer and consumer on Java, as well as is generating those events that I'm producing. And these events that I'm producing have a specific schema that I have in from my source before my migration process, right? And we can see how that looks also. It's not up yet. Now starting all the volumes. So you can see Nessie catalog as one of the containers. And then you have MinIO's AIStor. And you have Kafka. This is the Kafka UI that started. Then this is my data pipeline that is actually doing the producer and consumer. MinIO has Prometheus. So Prometheus is a way to go and look at some telemetry data straight from AIStor. And Grafana is showing you some of those graphs related with it. So now all my instances are up. And if you look at my browser here, okay, so yeah, so I pushed about 1 million events. Let's see. Yeah, it's actually writing those messages right now. So you can see those numbers go up here. So if I do a Docker logs, all right, looks like it completed. So it wrote about 1 million events was written, and then these are some stats that I am producing just for me to know how fast it is going. So you can see the 1 million events show up over here. That means it processed all those 1 million events that I generated. This is my consumer. Yeah, so if we go to the topics, you click on the topics, and you go to the messages, it gives you this is how the message looks like. So I'm generating an event GUID. I think this is my source before the migration happens. This is the timestamp. That is an epoch timestamp to it starts from January 1st, 1970. And then this is the country. And so this is the way I'm generating. So I have a hash that comes out with some number, random number in the end over here. And then these are some things to show action or whatever that field is over here. Mostly the schema over here is reflecting a type of, like, if you were to go to your website and you're on some page and you want to get some events on when someone's clicking on something. So what type of action they did on that page, or what type of device they were on, with user ID they are to click on that page. So you get some of that information to find out who is churning, which pages are more popular than others in your website, so on and so forth, right? So this is just a pure example. And every event, it's best practice to have an event GUID so you can look for duplicates and things like that and reprocess it, because sometimes from a device it might be sent multiple times. So that is a possibility. And so this is what it looks like, right? And all the events are processed here. Now, if we go to MinIO here, let me just log in. This is MinIO AIStor's console. And so it created raw data, JSON data. And these are all the JSON data that it has. Then I also do aggregation in my code. So when it's getting, it's aggregating at the same time. These are some stats, and these stats are reflective of what you saw over here. these numbers. It just tells what the 5-number summary and the percentiles look like in terms of throughput. And that's useful to know, especially when you're on a cluster, because everything is distributed. And this is Prometheus that helps you set up some of these, but actually the role of Prometheus is to pull the data from MinIO's AIStor and send it to Grafana. So here you need to log in. And I'm going to skip all that stuff. I don't want to put any new passwords. So you can see for the last 6 hours, for example, these are some numbers that come directly from, it'll update it over here because it's going through a process. And here you can see how it reflects here. So this for 748 megabits were processed, and it gives you some numbers like that. So here we are going to talk more about Iceberg. And one thing I wanted to say is that when you want to convert your data to Iceberg, you want to make sure, like, hey, what schema was I in? And this is the schema that was there for my source before my migration. And what does it mean to actually migrate the data over, and how to do that, right? So schema is a very important aspect. Remember, when you're in Iceberg, Iceberg is relying on Parquet, and Parquet is compressed columnar store. So take advantage of that, right? And so how you store the data, you want to make sure that you are compressing it as much as you can so you can get as much as you can from your drives and your throughput, especially when you're on-prem. The other thing that you want to think about is you want to make sure that every time you run an Iceberg query, whether you're joining 5 or multiple tables, first thing is like decide how your data model is going to look like, because that can actually help you in the future to make your queries to be sub-second. So, whether it's star schema or snowflake type of schema, or maybe just pure data sets, do what makes sense so that your speed is fast, the compaction is good, you don't run out of drives, and when someone's writing a query, that it's actually going through the number of partitions that it needs. So you understand what type of queries are getting executed. That's what I would say. Like, if you look at your surface area of how data is accessed, that's one thing you want to study when you do the migration itself upfront. So you know that I'm expecting the data to be queried in this style, and these are the 6 or 7 different patterns that it's going to happen. So when that happens, I want to structure my schema in a particular style. I want to make sure that I'm actually storing it, and the compaction that I'm getting out of those columns matter a lot, right? So that is the whole purpose of Parquet, is to compress your data on S3 and when you're on the cloud. And when you're on-prem, you get way more speed when you do that. So schema analysis is a very important concept. And then the other thing is partition sizing. We spoke about this. Important to understand, like, what does it mean when you transfer data from one data format to the other? When you think about CSV, for example, nothing is compacted. So everything is at the row level, and you have repeats, right, of every row sometimes, if it's denormalized sets of data. But when that is in Parquet and snappy compression, or if it's doing Z ordering or something to that effect, you're going to see way less. It's like using run length encoding algorithms to do that. So your sizes of those files are way smaller, and therefore it can read way more, through the network. And so that's what you want to try and look for. Also, you want to make sure that you're smart enough to scan the right sets of data and not all the data. So an important aspect is think about your partition strategy. Other things is like think about what catalog you're going to use, right? So it depends on your stack. And one of the things that I would say is that um, look for something it where you can manage that well. So Nessie is been used widely a lot and has less bugs compared to the other newer ones. So, for example, Gravitino is very popular, but you need to have your own catalog. It's kind of like a wrapper of the catalog in a sense. So there's more stuff to do, but it's more flexible. So really, you have to figure out like how much time and effort you want to spend on a catalog and whether that is worth it or not. Like if you have a day, if your tables and your entities are like in the hundreds and I would say in thousands, like in eBay, for instance, uh, then yeah, you want to invest heavily on a really a catalog that can scale. If you have only like if your data set is narrow and deep, I would put it in that way where you don't have many entities, but you have a deep data set where each of those tables or that data set is in petabytes, but you just have maybe at the most 10 tables. Like an auto management system is something similar to that. Um, then the catalog needs to just keep track of certain things and not all of the entities. And so you can scale down on that if you want. And then also another aspect that you want to think about is what does it mean for the workloads? Like, are you having a situation where upserts and to existing rows, like not appends, but upserts are happening regularly? In that case, then you want to think about what does it mean to go and update a row all the time? And so you want to reorganize it in such a way that you're leveraging append-only type of architecture. Therefore, you're in a better shape to travel back in your data set so that you can pull what you need. The moment you try to do updates on the lake, then you're at a point where it's possible that you may lose information if the updates are not right, because the rollback strategy of some of these are not where they're supposed, not comparable with RDBMS, for example. Like in Postgres, you could update like 50 different tables, but then roll back in the end and nothing changes, right? So you want to be in a situation where you actually take that into account in what your read workloads and your write workloads look like. Are you having too many updates? Are you treating your Iceberg as an OLTP system? That's not a good use case for that. It is a good use case for treating your Iceberg as for analytics purposes, not for live online transaction processing system. So those are the things you want to keep track of. The other thing as you go down is this is the part where we covered initially is what does it mean to do the migration? Whether you want to do bulk, that means, hey, everyone at the company, this is going to be down for X hours, and then we're going to move over to the new one. I would say that has a lot of risks associated with it. If things don't go right, then that's a problem. But yeah, I think I want to actually go and run the Iceberg code that does the bulk migration in this case. I ran it earlier, but I'm just going to rerun it again. So this is the code that actually does it. So it's very simple. It is actually connecting. It's creating a Spark session and a Spark instance to do that. But it's actually talking to MinIO through the S3 API interface, and then it's going and creating the namespace on Nessie, the catalog that we're using over here. And so that Nessie setup is here. These are the things that you need to keep track of. Like if you to kind of connect with Nessie. So Nessie's URI is this one is my local host that's running on that container. And then you're actually doing the transformation. That is the main purpose. So what you've seen on this screen over here, this message, how do you actually move this over to Iceberg, right? So you figure out what your data set looks like. You write the appropriate custom transformations that are necessary. But after that point, I really don't prescribe and tell Iceberg that I need to define the schema in such a manner. But it is always good practice, and it's production grade practice to actually prescribe the schema. In this case, I'm describing. I'm creating the table this way. So here's the main part. So you create the table in Nessie using Iceberg, and here I'm partitioning by year, month, and day. Right now I loaded 1 million events, but they all happened and finished in like less than 5 minutes. I could load 20 million events, and that will take about like 10 minutes on my local setup. But if it's on on-prem, proper like production grade kind of thing, you could load 1 day's worth of data or 15 days worth of data, and it might take a couple of hours. So that could be split into what that is. So here, my year, month, and day is reflective on the server time, like when it's running, when it's doing the stuff, and it's looking at this particular timestamp here, right? So if this timestamp was an old data, like 15 days ago, and you're running for like from, let's say, October 1st to October 15th, then you'll see the year, month, and date would be reflective of that timestamp. This is if you have this in your source. So those are the things you want to consider when you actually go and do that. Or I'm sure there will be other fields that might be derivatives of that you can figure out what that might be. But as an example, you construct the SQL that it needs to come out of there. And here I'm just creating a data frame and trying to go through and figure out what those columns are as I'm reading from the source from JSON, and I'm writing it to the data frame. So at that point, I have everything in the data frame, and then the Spark SQL can also understand that data frame. And so the data frame is actually acting between the JSON and the Iceberg frame in this case. So yeah, at this point, the table is created, and this is the data frame's name. I call it source data, and that's pretty much it. And then after that, I can actually go and run some things and see. So here you can see the records in Iceberg is now 1 million records, and I also list out the partition and some of those details. So if we go over here in MinIO's AIStor, and you come down, let's see what the time is. Let's see Iceberg over there, and so this is the events. So in this example, I took the raw events and I just converted that to Iceberg, and I also did that partition like you see. And these are these are Parquet files, but the metadata is the one that actually what we call the Iceberg. So in this event, this metadata, it created the metadata JSON that kind of tells you like what the snapshot kind of looks like. And for this particular thing, where are the snapshots? So anytime anyone does an update, you have a new snapshot. So it keeps track of that. And you can actually go programmatically and say, oh, you know what? I want to go back to this particular state of the table as of some time in the past. And you could actually programmatically go and update this metadata JSON so it reflects the right snapshot. And all of this other things over here are related with this exact snapshot, what that was meant to be, and what it was doing. And it is reflective of this one file. So we'll go through that part. So yeah, so in this output, I'm just showing the schema that got generated in Parquet, in Iceberg, I mean, and then some of the transformation that was happening and how that got the output related with that, as well as just describing the table in Iceberg. Okay, so so now that I have this, let's go to Query Iceberg. So this is a notebook where I have I'm basically querying the Iceberg data that I'm producing here, so you can actually look at it properly. Others, you have to go and read the Abro file and see a lot of things. And so this is just to illustrate that point. So let's see. Oh, these are some things that I need to do just to initialize stuff. And yeah, so it's querying the namespace over here in Nessie. So this Spark SQL, this Spark object is this Spark object, and it's it's saying, hey, how do I connect to MinIO AIStor? That's how you do it. How do I connect to the catalog? This is how I do it. And that's pretty much it, what this is really doing. And so at that point, I can query Nessie, and it'll tell me like, okay, the namespace that I have set up is raw, and the table that it created is in raw. The table name is events, and it's not a temporary table, meaning it's not a view. And then, so here, it's showing you what the table properties are for the table. So show table properties is like saying, like describing the table itself. It's the same thing. And then here's just an example to query the table. So here I'm doing a count from the total events, which is the name of the table it's the name of the field. The name of the predicate in this case, because I'm just doing a count from this table. And this collect is just a technicality of Spark SQL, just to make sure that I fetched all the rows. There's nothing more to that. And here I'm selecting star from the Nessie table, so it's like a select star. You can see all the columns. Let's go back to this example. So you see you have action shown up over here, and so that action is down here, and then you have category, which is also a field over here, country, device type, the event GUID, which is a stamp on every event. And there's also a flag called is returning, which is kind of like a businessy field that I created here if the user is coming back to that page. And then this is whatever the page URL is supposed to be. And how long they had been there on that page is the session duration. Then this is the timestamp of the event. And here's the user ID who went there. And this is some value associated with that user. And this is the timestamp of the server when this happened. In this case, this was the time it actually got written into Iceberg. So you have a server timestamp, like you can say persisted timestamp also, and just a reflection of year, month, and day over here. And if you want to, so here at this point, I'm showing you how you can get other informations about the table once it's in Iceberg. And so these are some of those examples. And here's another one that if I rerun this again, you could do things like group by country, do a count, average sum. If you were not having Iceberg and you were just having Parquet or just JSON, you'll have to, in this particular case, you have to have a Spark. You have to convert your JSON to a data frame and basically at that point write Spark SQL on top of that. But you have to write it in a specific way to get the most out of it. And so sometimes that might be a little more involved. In this particular case, like anyone who's got an interface to the Iceberg table, maybe you build a UI on top of this so that people can query the data that they need. or if you're using Tableau or Power BI, for example, and you want to write a query to your Iceberg table, you can easily do it that way too. And that's what this is. This is a standard query that you would group by country, look at some average sum, and count by country on something. In this case, I'm taking the value that might be having some specific meaning and might be a score or something to that effect, right? So, and then here we have, it's just a similar style, is a different slice of the data. In this case, I'm looking at the different types of actions that have been performed for that hour or for that entire table set, and looking at what that percentage of those actions are. How many people, how many actions were performed, or an average of 20,000. And this is because the way I generated my code, I made sure it's random to some degree. So you're going to end up seeing the same numbers for everything. And this is events by category, same thing, same story, whatever I told before, but just a different slice. In this case, I'm writing, this is just to illustrate, you can pretty much write whatever SQL you want to write on this table, just like any other ANSI SQL, right? And here's another useful piece. So for those who are doing, when things are in Iceberg, as a database administrator in the old world, in the new world, you would be looking at this metadata just to make sure things are right, has got the right snapshots, nothing is lost. And so if people want to travel back in time on that table, they can, that kind of thing. So some of those informations are like, hey, when was the last committed? What were all the commits? In this case, I have only one commit, so that's what's supposed to do. If I had 5 commits, I would have 5 entries over here. And so that has a snapshot ID. That snapshot ID is actually coming from here. So whatever that snapshot ID is, if you pay attention, you can see this number 5161 and so on up to 27 is actually this number that you see here, but it's also inside this Avro file. So that's one thing. And if you pay attention some more, you'll see the 988 and this number over here. That is basically saying this is with the first, what are the details of that particular snapshot is inside this, which lists all the manifest files, which says here are the parquets that changed. And that'll be the list of all those parquets that you saw in the data folder. This is the metadata folder. So in the data folder, which is here, data folder. Yeah, when you go down, let's see all of this stuff. So, and then yeah, you could have a parent snapshot, or it could have something to that effect. And what type of operation was performed over here? There's merge, there's updates, and that can happen as a reflection. Deletes can happen and things like that. So that operation is also specific. So it's good for debugging purposes. It's good for deciding, like, at some point you want to do snapshot management also. Like if you have millions of snapshots, like you don't want to store all that in your catalog, or in the end something will actually run out of space somewhere. So you want to be at some point you don't want all of those old snapshots. So you could write APIs to actually get rid of something at some point and say, we can't go back anymore. I mean, the snapshots are at this point. So, and then you can decide, like, oh, those files, which are those Parquet files that have never been called, never been connected with any of these, or we could say dangling Parquet, and the Nessie's catalog would have APIs to go and clean that up also. You could do that too. So some of these catalogs have certain advantages to focus on. So I would say, like, to do the right research in terms of, like, depending on your scale and how much time and investment you want to put on your catalog, you decide like what's the right catalog for that particular size of that data and for that type of reads or writes that are happening, and how often updates are happening or merges are happening. And then see what those capabilities are on each of those catalogs to decide, like, what that is. And every company is different, and there will be different needs. I can tell you, like, even if I tell you Nessie, for instance, it probably won't work for all of you. So you have to do that due diligence based on your environment and how your data is getting processed. Only you'd know that. So coming down here to the Iceberg data files. So this is just listing all the data files that it's actually pulling from here. So you could actually even stitch and say that, oh, this particular data file here is actually associated with this snapshot in this meta in that list. Yeah, and so here I have to, just to get the right one, because I ran this earlier. This is the generated set of folder that comes out from here, but you have full control in terms of like how you want to name these things. If you want, you could do that route. I would do that in production. I don't want anything to be in production where the code is actually deciding what it's supposed to be. Everything is, I want full control of all that stuff. So here I put whatever it is generating in this particular case. And yeah, it's just listing this manifest files over there, just like whatever you saw over here. So from code, I'm doing it this way. And it's basically like I'm making a list object and just doing the comparison and pulling it out that way over here. In this case, I'm actually reading the metadata JSON and pulling what's in that metadata.json. And what it has is, it has a schema. It tells me there's 15 fields and there's different types associated with it. It tells me what the current snapshot is. This is something that you can go and point, like if you say, hey, there's something corrupted now, I want to update my metadata JSON to be reflective of another snapshot in the past. You could go and write the correct APIs to update this JSON so that it's reflective of that. And therefore, when I'm writing a query, suddenly my query works. Okay, so, but you want to be careful about making sure that the data makes sense also. So that is a very important aspect. And here, this is just listing the manifest list files, basically saying that this manifest JSON references this snapshot, and this snapshot's referencing this manifest list, which references all these Parquet files. And yeah, let's see. We're running out of time. We are running out of time. So that is kind of like where I want to go with it. Let me know if you have any more questions. All right, I really want to thank you for your time to be here and just get an idea what Iceberg is, and also like what's the coding associated with it, and so on and so forth. It's pretty simple and straightforward, but really the tough part of that is to figure out like how you're going to do your migration, because that really can break or make it. I've done a migration that lasted about 8 months. It was like over a petabyte set of, I would say like 5 petabytes data that I was migrating over while the systems were running and while all the games were running, live games that you play on your devices. So nothing can go wrong and nothing can go, like you can't have a downtime. That company would go down. So those were those kind of things, like you have to be really surgical, like a surgeon, and decide like what you want to replace, what you want to, which moves you want to do next. All these things you want to plan ahead of time. You don't want to figure that out in the middle of the migration. That's really not going to help you make the right choices. So I think the first 2-3 months I spent just doing that planning, making sure all my stakeholders were on board on that one, and that's how we're going to execute on it. And then and then at that point you can close your eyes and just do it. There'll be points where certain nuances will come up, but it's not like the end of the game. So really pay really deep attention to your current architecture and what you want to get out of it once the migration is done. Like, how does that look like? That has to be super crystal clear to you, and in terms of how you get it before you even touch the keyboard. So that's what I would suggest. All right, thank you very much for your time here, and wish you good luck.